Good morning. We are pleased to welcome Stan Pala, the Global Sales Director of Oilseeds at Solex Thermal Science. This is an interesting topic. Solex has been in the industry for many years, and they are innovating the way you condition and use heat for soybean processing. And we are looking forward to hearing from Stan Pala, especially in terms of the constraints which the African subcontinent is facing. In general, the African subcontinent is got a deficit in oil production and oil usage. They import more oil than they produce, and the production is impacted because of lack of financial resources, raw materials, processing and packaging regulations, along with market accessibility, which Mike explained to you about transportation. I talked to a processor who has industry in Africa, and he told me if it takes 40 points to move a pound of product in the US, it takes about 400 points to move the same pound of product in Africa because they do not have railroad technology. They depend upon trucks, and trucks depend upon roads, and roads are not very good. And there is chance that the product will not get, and supply chain is severely impacted. I'm sure it's getting better, and I think everybody understands the need for it, but it'll be interesting to see and hear from Stan on his thoughts on the equipment and how they are going to solve the uh, supply chain demand issues. Take it away, Stan. Welcome.
Hello. Thank you, Nora, and thank you, Amy, for the introduction. And hello, everybody, and I would like to welcome everybody at this symposium focused on soybean in Sub-Saharan Africa. And first of all, let me thank you to the AOCS organizers for the opportunity to present our contribution to the oilseeds industry. My name is Stan Pala. I've been with Solex for a little than 10 years, and I'm responsible for the development and implementation of the technology into oilseeds industry globally. Generally, Solex Thermal Science is a Canadian company that came up and developed the concept of a plate indirect technology for heating and cooling of bulk solids. And in addition to this, Solex has later developed plate conditioners to provide this energy efficient solution to majority of the oilseeds processors, including soybean processing either with warm or cold dehuling type preparation. Solex has applied this new technology on the very first installation in Canada on urea, cooling more than 30 years ago, and till now the unit's still working well, still with the original parts, and this just shows the robustness and reliability of this solution. Very quickly, a brief history of Solex, and what is worth mentioning is that first oilseeds conditioners were installed in 2006, and again till now they still work and are equipped with the original plates for the heat transfer, which just proves a lifetime of a minimum 14 years plus, and therefore very little maintenance costs associated with the operation of the plate technology. In oilseeds, there are about 60 installations globally, mainly on rapeseed, soybean, and sunflower. And majority we can find in preparation plants. The technology can serve small capacities ranging from, let's say, few tons per hour, as well as the large production facilities operating with over 5,000 tons per day or higher. However, for each capacity, the majority of the advantages that I'm going to present can be offered. So before we look into oilseeds conditioning and its challenges, so let me just quickly show you how the indirect solid technology works and how it looks like in general. So on the right picture, there is a card or a drawing, an example of the plate technology for the heating and cooling of bulk solids, including variety of oilseeds. The heart of the conditioners are stainless steel heat transfer plates, that are generally two metal sheets welded together, inflated under certain pressure, and are individually connected to manifolds with flexible hoses. This generally allows thermal expansion that is usually an issue with the tube technology and weld cracking. And you can see the details on the left picture where the pipe represents manifolds for the distribution and collection of the heating media. And you can see that each plate is connected independently. This means that if something happens with a plate, it can be isolated without long downtimes, meaning huge production losses generally. The heating media, and it can be steam, high or low pressure, condensate or hot water, flow inside the welded plates, either upwards or downwards, depending on the configuration, so co-current or counter-current. The conditioners are always kept full of product, and on the right picture there is a level of product above the plate, and you can see that the product is falling through the inlet nozzle on the pile of product. At the bottom of the conditioner there is a discharge feeder, and the primary function of the discharge feeder is to keep the units always full of product, basically not to expose the plates. And the product itself is flowing between the plates by mass flow with very low velocity, and we can say approximately 0.5 meters per second. And therefore the plates do not suffer from abrasion, which is great benefit. And the actual heat transfer is done by the conductivity. Well, during the development of the indirect solution, we are observing and discussing operational issues with many soybean processors globally, which at the end we are able to identify as. First one, and the very common, is that there is a low-grade energy available at the plant, mostly from another processes, and there is an economical and environmental motivation to reduce the steam consumption in the preparation process. And this has been quite necessary to remain competitive, and obviously savings on the processing cost will go directly to the bottom line. Increase of the production, generally studying the total crushing rates, and we can find this information basically on internet, over long-term period, we can see that the total crushing amount is growing, and obviously this needs to be followed by the crushing capacity. And it's difficult not to notice that the production rates and many plants have been maxed out with the production lines of plants, let's say 20 or 30 years old, and the producers are looking for options how to increase the production rate at very minimum capex. Then another point is that some of the installations are simply too old. Again, like some plants ranging 20, 30, 40 years. And still with the plants using the old technology, for example, cold or hot deholing process, that obviously were revolutionary at the time of installation. However, step by step, these old installations become obsolete and replaced by more efficient technology, for example, switching to warm deholing, which is much less energy demanding process. Another very important reason that we often hear is the actual condition of the existing equipment, together with the very high maintenance cost, requiring tubes replacement in rotary or vertical seat conditioners. The bad condition is usually caused either by abrasion or weld cracking due to the thermal stress, as all these equipments run on steam only. And the last but not the least, and also very common reason, is increased moisture in the seeds. That obviously differs from one region to another, but we hear from our clients it's a fairly common issue of soybean, for example, imported from Latin America. And in terms of the existing equipment, is an issue, as it was designed to a certain specification, mostly lower moisture removal capacity. And this is an issue for the quality of the final product and the yield efficiency. All the producers simply needs to decrease the production rate to meet the downstream product specification, resulting in significant production losses. Well, to address these challenges in soybean processing, we focused on the development of indirect heating technology and came up with a solution that meets the criteria and provide a solution for majority of those issues during the conditioning at the preparation plants. I will start with the bean heating modules. Basically, we have two solutions to offer according to the complexity of the needs. First one, as I just mentioned, is a very interesting solution. We call it Solex bean heater modules, and basically they allow for increase of the production rate in the existing units without elaborate and expensive retrofits to replace updated and round down tube sections. On the picture, the modules can be noticed itself mounted on top of the standard vertical seed conditioners right below the inlet hopper. This solution of the modules, together with the innovative plate design, doubles the heat transfer area in the same volume compared to the tubes. The compact design allows plants to increase capacity by adding heat transfer area in the same volume and footprint. This can be achieved either by adding additional modules on top of the existing systems or replacing existing tube modules that have worn out, for example. The plate design also allows for a wider range of choice of heating media, not just steam, but it could be, let's say, high and low pressure steam, condensate, or hot water. Or the plant can enhance the total thermal duty of the unit by switching to higher steam pressure, as I just mentioned. The modules itself are completed out of stainless steel plates mounted on the casing, in the casing, and connected to the manifolds for plant heating media hookup. The modules are designed in identical dimensions as the existing vertical seed conditioners known on the market, and this allows a quick and easy replacement with minimum cost, and you can stack up a number of modules on top of each other to meet your new plant requirements. However, the bean heating modules didn't answer and help too much if there was a need to increase the moisture removal capacity, and still use the advantage of all the benefits resulting from the plate indirect technology. Therefore, bean heating modules were combined with the innovative air sections to provide heating and conditioning at the same time. Modular design itself, it's particularly suitable for a combination of waste energy recovery in the top sections, and the lower parts will accommodate steam for a powerful evaporation of the moisture. Between the heating sections, you can notice optimized air modules that have adjustable louvers for optimized drying performance in order to achieve even better drying across the entire bed of product. And the air sections are boxed with manifolds with access hatches for easy cleaning. The flow of product is controlled by a discharge feeder in a way that the conditioner is the entire time of operation full of product. And the conditioners are controlled by the temperature and amount of the heating media, mostly steam or hot water. And the drying rate is then controlled by the heat intake. And again, that heat is coming from the heating media, mostly from the steam, providing the actual evaporation. An amount of air just controls the saturation inside the conditioner and controls the drying performance. So this is the biggest difference compared to the grain dryers that use the hot air for the evaporation and for the drying. Here, basically, we use the heat to heat the moisture inside the beans to evaporate, and then we just use the air to carry the moisture out of the conditioner. Generally, the plate technology within the soybean industry is offered with the dimensions of the common vertical seed conditioners, and the same applies for the bean heating modules. And generally, it is 3.3 by 3.3 meters and 2.4 by 2.4 meters. Or we can design just a tailor-made solution to fit individual needs. The heat recovery is, this is one of the focus of my presentation or paper today, and the heat recovery is a very powerful topic, allowing the producers to achieve higher processing margins and to stay basically competitive on this highly competitive market. And the price of the oil and meal as a commodity is something that producers probably are unable to influence directly. However, the cost of production can be optimized, and taking the fact into consideration, The steam consumption accounts for about a quarter of the total processing cost. The reduction on steam consumption makes perfectly sense. This also can be connected to government subsidies for energy and CO2 emission savings, depending on each country, obviously. Well, with the definition of low-grade waste energy, we know that generally it is a type of energy that is very difficult to recover due to its very low temperature. And usually we're talking about energy that has about temperature, say 60, 70, 80, 90 degrees. And in oilseeds industry, it will be, or oilseeds processing, it will be mostly condensate with a temperature around 90 degrees, hot oil in the range 80, 90 degrees. Again, vapors from either from the cookers in rapeseed processing or vapors from the DTDC at 70, 80 degrees. So theoretically, the maximum heat recovery that would be possible would happen if the temperature of the source of the waste heat would equal the temperature of the seeds at the inlet of the vertical plate conditioners. So the gap between the green arrow and the black arrow on the screen would be zero. However, in the real world, this is impossible, and we would result in an indefinite size of the heat transfer area. So following the thermodynamics law, it is obvious that if we want to target for an efficient waste heat recovery, we'll need to minimize logarithmic mean temperature difference between the waste heat and the seeds. And as a result of this equation, we'll basically need a very large heat transfer area. Therefore, we're now talking about the plate technology. When the oilseeds producer decides basically there is a time to increase the processing margins or to reduce the amount of the energy used for the processing of variety of oilseeds, here we're talking about the soybean. And before they start investigate and maybe reduce the steam consumption, first the source of waste energy and its recoverability needs to be addressed. And in a typical soybean processing plant during the years of Solex present, we have identified major sources of waste energy, and those will be, for example, flash steam. Sorry for that, or condensate from variety of extraction processes, or cooling of gas engine or gas turbine for the efficient operation of the equipment, or for example, vapors from dryer and cooler. Boiler flue gases with the installation of an efficient economizer, and basically other sources from another processes, or we can actually think about the vapors from the conditioner if we are able to collect the vapors and they are having basically certain quality with the RH and with the temperature. The reason why we're talking about the plate technology is that we can definitely claim that plate technology can offer the advantage of a very, very dense heat transfer area. And if we, for example, compare plates on the slide on the right-hand side with the tubes on the left, that are a very common solution within the oilseeds industry in the form of vertical conditioners. Eventually, we can also mention rotating conditioners as a very common solution. We can say that both technologies use similar principle of heat transfer and mass flow, except rotating equipment. Both technologies are very efficient solution, especially if we do not consider heat recovery. However, the plate technology can offer twice as much heat transfer area within the same space and the heat recovery at the same time. For example, one heating section with a typical dimensions of 3.3 by 3.3 meters and 1 meter tall modules offer more than 420 square meters of heat transfer area, which compared to the tubes that have approximately 180, 190 square meters is literally twice as much. And being able to process more product within an existing space is important for plants that are looking to increase the production capacity without having to undertake significant retrofit renovations. Simply put, you cannot install more tubes into the same area, and they would have to occupy additional space, mostly outside of the existing processing plants. And this just means additional investment into new buildings or platforms, new transportation of the product to and out of the conditioner, and new utilities distribution, which basically is increasing the capex. Generally, if the producers choose the plate technology to recover the low-grade energy from a waste heat, it needs to be with the help of a heat transfer medium, and it will be most likely hot water. The hot water loop will have at least 2 heat exchangers. So the first heat exchanger will be for the source of the heat, and it could be variety. It could be several heat exchangers, obviously, because we can have several sources of the waste heat. And obviously, the second heat exchanger will be the vertical plate conditioner. And in both, at the same time, we need the most efficient recovery. And this can be done only if the hot water loops operates with the very low flow rate, basically as low as possible, as the equipment can handle. However, the limitation is that a minimum critical velocities inside the heat exchanger needs to be maintained, as we know from, let's say, from the theory of the design of either for the shell and tube or plate heat exchangers, for the turbulent flow inside the plates in this case. Otherwise, the distribution of the hot water inside is generally very poor. And we can say that due to the profile of the plates, there are as I mentioned, 2 welded metal sheets together. And after an expansion as a production step, they have corrugation, and at the same time, the possibility to integrate a certain number of the internal passes. We can increase the velocity inside the plates if needed. This means that the plates in general can maintain much lower flow rates necessary for a maximum and efficient heat recovery at the same time. This is basically another of the major advantages of the plate technology and its feasibility for the heat recovery. And we can say that for this reason, majority of the heat recovery installations globally do actually have plates. Excuse me. Slide less. So we have learned that for an efficient heat recovery, we'll need a large heat transfer area. However, each organization or plant has a different maximum time for the return on investment, and this needs to be considered for the total investment. As you can see on the graph on the right hand side, the more heat we want to recover, the heat transfer is growing exponentially. So at certain size of the heat exchanger, the payback time becomes too long, and the entire project can be easily killed. Therefore, it is very important to find a sweet spot, considering other circumstances that are influencing recovery rate, like summer and winter conditions, where winter offers much bigger opportunity for the heat recovery due to low seat temperature at the inlet, or the quality of the waste source, for example, saturation of the vapors from DC or from the cooker, and many other considerations. However, with today's thermal modeling software, it is relatively easy for us to fine-tune the system and find the best acceptable solution. Regarding the plate technology, we can say the technology itself can challenge the low-grade heat, and with a smart integration into vertical plate conditioner, a large portion of the heat available can be actually recovered. For this purpose, we can use one of the advantages, and that is actually the module design. On the screen, you can see a stack up of individual modules and dedicate few top modules to bring the waste energy back into the process. And the typical arrangement will be with a hot water recovery loop on the slide on the left, or hot water and fly steam on the right hand side, with the source of low grade heat on the primary side of the hot water loop, and obviously it can be multiple sources, as I already mentioned, and Solex conditioners with the seat on the secondary side. Generally, there are a number of variables that will influence efficiency of the recovery. However, the heat transfer area is one of them. We can dedicate number of heating modules only for the recovery, and on the diagram you can see there are 4 of them. But generally, adding more sections will not bring the effect, as the temperature of the seats inside the conditioner will already reach the temperature that the further recovery will not be efficient. In average, in one heating module or one section, whatever we call it, with a size of 3.3 by 3.3 meters, we can claim about 5 to 7 kilograms of steam per ton of soybean processed to be saved. And for example, if we go for maximum 4 modules just for the heat recovery, will be getting about 20 to 25 tons of steam saved per ton of soybean processed. And obviously, due to the nature of the heat recovery, the first sections, due to the temperature of steam, will be more efficient than the bottom one. And in total, for example, for a 5,000 tons per day production plant, the savings will represent approximately 600,000 USD per year, and return on the investment between 1 and 2 years, assuming approximately, let's say, 20 USD per ton of steam. And obviously that varies from one continent or from one country to another. But we can say that each case needs to be calculated individually. Well, for let's see, so many times we heard the question about the lifetime of the plates, and frankly speaking, it was difficult to answer because we never experienced these types of questions. I already mentioned that Solex has started with the plate technology about 30 years ago, and majority of the first installations were in the fertilizer business for cooling of granulated fertilizer. And in this industry, the main competitive technology was a fluid bed, and simply the lifetime of the equipment was not an issue. However, in the oilseeds industry, we do have a variety of equipment that generally suffers from abrasion, and this is done due to the nature of the seeds that are very abrasive, and especially we can say rapeseed, soybean, and sunflower, and the wells cracking at the steam distribution due to the nature of the thermal expansion and the cracking around the wells. We can see that the old rotating conditioners. We can see that on the old rotating conditioners, the tube needs to be repaired every single year with expensive removal of tube bundle, rewelding, or inserting back into the conditioner. And at the same time, we can see it's happening on the old vertical conditioners, where the entire tube bank needs to be replaced or rewelded X number of years. This, in combination of material of construction that is mostly stainless steel, is making the tube technology is making the technology very, very costly, and the repair is making very costly. Not as capex, but in an overall total cost of ownership, where the maintenance cost for the replacement of the tubes needs to be included. In Solex, we can still see some original units in operation installed back in 80s, still with the original plates. And the same we can say about the first oilseeds units installed around 2005, and our clients do not observe any significant abrasion. Obviously, the plates are specified for certain quality of the fluids. The conditioners need to be isolated from the plant vibration, or the steam system needs to be properly designed in order to avoid water hammering. So if the general rules are followed, we can say that the plates will last the same time as the conditioner itself, and we can easily talk about, let's say, 15 to 20 years minimum. And at Solex, we can say that our plate technology helped to save significant amount of CO2 emissions and also other emissions like dust. And out of the 60 oilseeds installations, we can easily say that over 90% actually do have a heat recovery option installed and operated. And for example, for a typical 2,000 tons per day canola plant, when heating the seeds from, let's say, typical temperature 10, 20 degrees to 60 degrees, and if it's done solely by a heat recovery, the technology will help to save approximately 2,400 tons of CO2 per year. Obviously, not all the plants will have the same amount of heat recovered, and production rates obviously going up and down. However, still, if we multiply each plant of CO2 savings with the number of installations with the heat recovery, we'll get to the total number that we are actually really proud of at Solex. So thank you for watching this presentation, for joining us today, and basically, I hope that I was able to pass the information about the advantages of the technology. And obviously, should you have any questions, we hope that we'll be able to answer to your satisfaction eventually. Please do not hesitate to contact us directly.
And thank you for your knowledgeable discussion about heat exchangers And we have a couple of questions we would like you to address and talk about. The One of our questions is, can plate technology handle the same amount of impurities as tube technology? And what is your experience in this area?
Thank you, Nora. It's actually a very common question, and that's very valid question, and we are happy for that because for certain clients it can be fairly new solution, and generally we can say that yes. The positive news that is that the plate technology do not leak inside because all our connections are outside, so we don't face basically the same issue what let's say I wouldn't say majority, but many our clients facing at the end of the lifetime of the tube technology, where there are a lot of tubes around the belts already leaking, and once you have the leakage inside the conditioner, obviously it creates wet spots and it starts agglomeration, smoldering, and other issues basically that can lead to the very serious issues or complete blockage of the heat exchangers or conditioners. And in addition to this, our plate technology can handle also cracked soybean for the cold dehulling process with the maximum amount of the hulls. And because obviously sometimes some of the installations have a full, some of them have kind of partial dehulling. But obviously, in many plants, sometimes there are offset conditions, and all the holes can flow through the conditioner. And we have a number of these cracked soybean conditioners, and actually they are working very well. And we are very happy to also offer that technology for the cold dehulling.
Thank you. I've got one more question for you. I'm sure you have explored the space in Africa in this heat exchanger technology area. And how do you intend to increase your footprint in that area? One of the main concerns which we keep hearing is the ability to pay for the equipment and the high cost of new technologies and how that can be incorporated in the sub-Saharan African space.
Right. It's a very valid question, and obviously, as I mentioned, one of our major benefit is the energy recovery. So we are actually very lucky that we can offset the cost of the equipment with the energy savings over the time. Obviously, each continent, each country has different cost of the gas or oil, basically any source that is generating the steam. And we know that oilseeds processing is very steam demanding process and can represent big portion of the total cost. So obviously that's a valid point, and we are kind of happy with each individual producer to sit down, to connect, to visit, and kind of go through the individual sources and try to find the spot. Okay, if there is not big portion of the waste energy, obviously how we can basically cause the project that it's acceptable in terms of the ROI, return on investment. Do they need to, let's say, for example, for the bed, do the conditioner needs to meet the maximum performance for the entire year, or is it only for 2 weeks, 2 weeks time, a year? Maybe we don't need to let's say cover all the peaks, yearly peaks. Maybe we can offer a solution that will work on 100%. Let's say majority of the year, and for a very short period, it might maybe need to reduce a little bit the capacity. So basically, we need to kind of offset the energy with the capex and find the right spot. But I'm assuming the price of energy in Africa is not particularly low. So I think the technology is very feasible. It is very feasible in Africa compared to the states, compared to the countries where the energy is very low, or the cost of energy is very low, like for example in Russia, or it could be also in the United States. So particularly in Africa, I think it's actually a very interesting solution.